Welcome back, everyone. Ready for another deep dive? Today, we're going to be looking at something you probably use every day without even realizing it.
I bet they do.
HTTP headers.
Yeah, that's right.
HTTP headers. So, I mean, most people are just browsing the web, right? They don't think twice about them. But HTTP headers are seriously crucial. I mean, they affect everything from like how quickly a page loads to, security, keeping your information safe.
Yeah, absolutely. They really are the unsung heroes of the web.
So for this deep dive, you sent me a bunch of articles and research on, well, all about HTTP headers, plus your own notes on how it all connects to Axios, which is it's a pretty popular tool for developers.
Yeah, exactly. For this deep dive, I'm hoping you walk away understanding not just how important these headers are, but also why there's so much debate about, like the best ways to work with them. Especially this whole Axios versus Fetch discussion that's been going on in the development world.
Okay, that sounds like a challenge,
hmm
but I'm up for it. So let's back up for a second. What exactly are HTTP headers? I mean, I get that they're like part of how web pages work and load, but
hmm
can you give me an example, like something somebody who's not a programmer would understand?
Sure, sure. So imagine ordering a pizza online. You go to the website, right? You pick out all your toppings, put in your delivery address. That order gets sent to the restaurant as an HTTP request.
Okay.
But along with your pizza choices, there's, some extra information that needs to go with it, like delivery instructions,
Yeah.
leave at the door, details about how you're paying, or even like preferences, like no anchovies.
Okay, I see where you're going with this. So the pizza order is like the main request,
Yeah.
and these extra instructions are kind of like the headers.
Exactly, exactly. HTTP headers are essentially like bits of metadata that travel with every request and response on the web. You can think of them like a little notes that provide crucial info to both the browser and the server.
Yeah, that makes sense. It's like those special instruction boxes you get on like online forums sometimes.
Yeah, exactly. They basically let the browser and the server talk to each other and make sure everything runs smoothly and these headers, they're not just for ordering pizza, they're used for literally everything from like loading pictures and videos to like even logging into your bank account.
So they're kind of like the glue that holds the web together.
I like that. Yeah, the invisible glue.
The invisible glue.
That's a great way to put it. And that's exactly why it's so important to understand them, even if you're, not a developer. Like knowing what's happening behind the scenes, it can make you a more informed user and give you more control.
Okay, yeah. Starting to get why this is so important. Now, one thing
Yeah.
that stood out to me in the research you sent was like different types of headers. Can you break those down a bit?
Sure. There are four main categories. You've got request headers, response headers, and then representation headers and payload headers.
Hmm.
So starting with request headers, I mean, the name kind of gives it away, but these are sent from the browser to the server with that initial request.
Okay.
They contain, info about the client, like what kind of content they're expecting back, and any other instructions.
So those are like the outgoing notes, like here's what I need.
Exactly. And then you've got response headers. Those are, sent back from the server to the browser along with the content that was requested. So they have info about the server itself, the status of the request, and any, instructions for the browser on how to handle that content.
So those are like the return receipt, like here's what I'm sending back.
Yeah, I like that. And then there are representation headers. These basically tell the browser about the format of the data being sent, like is it an image, video, or plain text. And they also have instructions on like how the browser should, display or process that data.
So those are like labels on packages telling you what's inside and how to deal with it.
Exactly. That's a great way to think about it. And then finally you have payload headers. These provide info about, the actual content of the message, like how big is the data, what type of encoding was used.
Okay, so those are like the weight and dimensions on a shipping label, like the details about the package itself.
You got it. Each of these header types plays a specific role in ensuring, smooth communication between the browser and server,
Yeah.
keeping things efficient and secure.
Okay, this is all making sense.
Yeah.
But you mentioned Axios before. How does that all tie into this?
Ah, yes. So as web applications get more and more complex, managing these HTTP headers can get tricky. Axios is a JavaScript library that basically simplifies making those HTTP requests and handling the headers. Think of it like a specialized tool that helps developers send those pizza orders and understand the delivery instructions, so to speak, but much more easily.
So it's like a high-tech pizza ordering app made just for web developers.
I mean, that's one way to look at it.
I like it.
Yeah, it helps developers send different types of requests, handle the responses and manage those headers efficiently.
And why is Axios so popular? I mean, is it just that it's easier than doing it manually?
Well, that's a big part of it, yeah. But it also has a bunch of other features developers love, like automatic JSON parsing, error handling, and the ability to intercept requests and responses, which is pretty powerful stuff.
Okay, yeah, that does sound powerful. And this is where that whole Axios versus Fetch debate comes in, right?
You got it. So Fetch is this newer API. It's actually built into modern web browsers. And there are some developers who think it's, a better choice than Axios. There are strong opinions on both sides, which we'll definitely get into more later on.
Okay, I'm definitely curious to hear more about that. But before we get into that Axios versus Fetch showdown, I think it's good to understand why these headers are so important in the first place. You mentioned security before. Can you explain how headers are involved in keeping our online activity safe?
Absolutely. One of the key ways headers contribute to web security is through what are called security headers. These are specific types of headers that websites can send to browsers that tell them basically to implement certain security measures.
Okay, so they're like extra layers of protection that websites can add on to keep our data safe.
Exactly. It's like adding extra locks on your doors. For example, one really important security header is called Content Security Policy, or CSP. It acts like a bouncer at the website, controlling what content is allowed to load, and where it can come from. This helps prevent attacks like cross-site scripting, where malicious code could be injected into a trusted website.
Okay, that sounds pretty bad. So without these headers, a website could be vulnerable to hackers, right?
That's exactly right. Another important one is called strict transport security, or HSTS. This one basically tells the browser to only communicate with the website over a secure HTTPS connection, which prevents things like eavesdropping and data tampering.
Okay, that's super important these days, especially when we're doing online banking and shopping. So these security headers are kind of like the guards at a bank, right? Making sure only authorized transactions can happen.
Exactly. They help prevent a whole range of attacks and keep your online activity secure. And the best part is they do it all behind the scenes.
Wow, that's pretty amazing. So even though most people have no idea they even exist, these headers are working tirelessly to keep us all safe online.
Exactly. And as we rely more and more on the web for basically everything, from communication to commerce, understanding these fundamental security mechanisms, it becomes even more important.
Okay, this is all fascinating, but I have to admit my head is starting to spin a little.
Yeah.
We've covered a lot of ground.
Yeah, it is a lot to take in.
I know.
Why don't we pause here for a second and let you process everything? Anything you'd like me to clarify?
Yeah.
Or any questions that have come up so far?
Let me think. I guess what's really striking me is how much is going on under the hood. When you just load a web page, it's this whole intricate dance of requests and responses, all orchestrated by these tiny headers.
It really is. It's a testament to the ingenuity of the web, and we've really only scratched the surface.
Okay, well, I'm definitely ready to dive deeper. What other fascinating insights about headers do you have in store for us?
Well, next, I think we should talk about how these headers affect, the way websites handle different types of content, like images, videos, text, all that. And then we can finally get into that Axios versus Fetch debate that you're so curious about.
Sounds good to me. Let's do it.
Yeah.
Okay, so before we jumped into part two, we were talking about how these headers handle different types of content, like images and videos. And you mentioned content negotiation.
Right. Yeah.
Content negotiation.
Yeah. Content negotiation is basically how the browser and server decide on the best format to send content. It's kind of like choosing the right language to speak with someone.
Okay, that makes sense. But how does that play out in the real world? Give me a concrete example.
Okay, sure. Let's say you're on a website that offers articles in both HTML and PDF formats.
Yeah.
When you click on an article link, your browser sends a request to the server. Included in that request are headers that specify what kind of file formats your browser understands.
Gotcha.
The server then looks at those headers and decides, which format is the best to send back.
So it's like saying, hey, server, I can read HTML and PDF, so send me whichever one worked best. And the server's like, okay, you're in luck. I have both. Here's the PDF version.
Exactly. Yeah, the server uses that information in the request headers to figure out like the optimal format. And this happens all the time, not just with documents, but with, images, videos, even different language versions of a website.
Oh, wow. That's amazing. I never realized how much like decision making was going on, behind the scenes. So like if I had my browser set to like prefer German or something,
Right.
the server could like send me a German version of the website if it was available.
That's right. And that's all thanks to the accept language header,
Yeah.
which, tells the server your preferred language.
Okay, this is blowing my mind a little bit. So
Yeah.
how do developers use Axios to handle this content negotiation? Is that something they have to like manually code for every request?
Well, that's the cool thing about Axios is it handles a lot of this automatically. Developers can, set default headers for all requests so they don't have to keep specifying, like their preferred formats every single time.
Right.
But they can also, customize headers for specific requests if they need to.
Okay.
So it gives them, more fine-grained control over that content negotiation process.
So it's like having like a personal assistant, who knows all your preferences and can make those decisions for you most of the time. But you can always step in and give specific instructions when needed.
Exactly. Yeah, it's all about, finding that balance of automation and flexibility, which is one of the reasons why Axios is so popular.
Makes sense. Now, another thing that really stood out to me in the research was this concept of conditional request. Can you explain those and why they're so important?
Sure. So conditional requests, they're a way for browsers to check if a resource like a web page or an image has changed since the last time it was, downloaded.
Okay.
If it hasn't changed, the browser can, just use that saved copy, which saves bandwidth and time.
So it's like calling a restaurant to see if your takeout order is ready, before you drive
Right.
over.
Right, exactly. You don't want to waste a trip
You don't make the trip
if it's not ready yet.
if it's not ready.
And that's where headers like if modified since and e-tag, those come into play. These headers basically allow the browser to send information about like the last time they accessed that resource, and the server can use that information to decide, okay, do I send the full resource or just a message saying, nope, it hasn't changed.
So it's like a timestamp
Yeah.
that says, this is the version I have. Has anything been updated since then?
Exactly. Yeah. And if the server determines that, that saved copy is still good, it sends back what's called a 304 not modified response,
Okay.
which tells the browser to just go ahead and use the local copy.
That's pretty clever. So these conditional requests are like helping make browsing faster and more efficient.
Exactly. They reduce server load and improve performance, which is, especially important for people with slower internet connections.
Wow, I'm starting to see just how much optimization is happening behind the scenes. It's amazing.
Yeah, it really is. It's like a well-oiled machine.
Yeah.
And it it really highlights how important it is to understand these mechanisms, these mechanisms that are working, even if you're not a developer. Like
Yeah.
the more you know about what's happening, under the hood, the better you can make decisions about your online experience.
Okay, that makes a lot of sense.
No.
Before we move on, I'm kind of curious about something. We've talked about how these headers can be used for good, security, content negotiation, and even performance optimization. But can they also be used for like less noble purposes, like tracking users or collecting data without their consent?
That's a really good question, and it's definitely something to be aware of. I mean, while headers themselves aren't, inherently good or bad, they can definitely be used for different purposes, some of which, may raise some privacy concerns.
Right.
Yeah, it's like any tool. It can be used for good or for bad. It really depends on, the intentions of the person using it.
Right.
For example, some websites might use headers to set what are called cookies, which are, these little text files that can be used to track users' browsing activity.
Okay, so even though cookies are like a separate mechanism,
Right.
they can be like linked to headers.
Yeah, they're connected. The set cookie header that's used to send cookies from the server to the browser, and the cookie header is used to send cookies back from the browser to the server, with each request.
Okay.
So this allows websites to, remember things like user preferences, track their movements across different pages, and even like target them with personalized ads.
Okay, that's starting to sound a little creepy.
Yeah, it can be.
Yeah, it can be.
It
A little Big Brotherish.
it can be, but there are ways to protect yourself from this kind of tracking.
Okay, good, good. What can we do?
Well, a lot of browsers offer, privacy settings that let you, block cookies or control, how they're used.
Okay.
You can also, use browser extensions that specifically focus on privacy,
Yeah.
blocking trackers and preventing websites from collecting your data.
Okay, that's good to know. It's reassuring to know that we have, ways to protect ourselves in this complex world of HTTP headers.
Exactly. And it's really important to remember that knowledge is power. The more you understand about how these technologies work, the better equipped you are to make, those informed decisions about your online privacy and security.
Yeah, okay, that's a great takeaway. So we've covered security, content negotiation, performance optimization, and even, touched upon like the potential privacy implications of headers. What else is there to learn about these like behind the scenes messengers?
Well, I think it's finally time to tackle the elephant in the room, the whole Axios versus Fetch debate that's been brewing in the developer community.
Okay, I've been waiting for this. Lay it on me. What are the key arguments on each side?
All right, so as we've discussed, Axios is it's a third-party library. It's been around for a while. It's really popular for its ease of use, all its features and its robust error handling.
Hmm.
Fetch, on the other hand, it's a newer API. It's built right into modern browsers. It promises a more streamlined approach that's closer to the like core principles of HTTP
Okay.
and potentially better performance because it's smaller in size.
So it's like choosing between a really powerful all-in-one tool like a Swiss Army knife
Right.
versus a like simpler, more specialized tool like a precision screwdriver.
Yeah, that's a good analogy. So developers who love Axios often praise its user-friendly API. It's designed to be, really intuitive and consistent, which makes it, easy to learn, easy to use, even for complex requests. And its error handling mechanisms are really powerful. They make debugging and troubleshooting much easier.
So Axios is like the comfortable, familiar car you've been driving for years. Like it's reliable, easy to handle. You know exactly where all the buttons are.
Exactly.
Yeah.
Yeah, but Fetch advocates they argue that its native integration into browsers gives it this big advantage, right? Because it's already there. There's no need to include like a separate library, which could potentially lead to faster load times and a smoother user experience.
So Fetch is like the sleek new electric car that's designed for efficiency. It comes with all the latest tech built right.
Yeah, you got it. And they also point out that Fetch really embraces the asynchronous nature of web requests,
Yeah.
encouraging developers to work with what are called promises, which is like a more modern way to handle, asynchronous operations in JavaScript.
Okay.
This can lead to, cleaner code that's easier to read and maintain.
Okay, so it sounds like both Axios and Fetch have their own strengths and weaknesses. Is there a clear winner in this debate?
Not really. It really depends on, the specific needs of the project, the developer's preferences and the team's familiarity with each tool.
Okay.
Some developers, they really value Axios's extra features and ease of use,
Right.
while others, they really appreciate Fetch's simplicity and those performance benefits.
Okay, so it's not a black and white issue.
Right.
It's more about, choosing the right tool
Mhm.
for the job.
Exactly. And the great thing is, both tools they're constantly evolving, they're constantly improving, so the debate's, likely to continue for some time.
This has been an incredibly like enlightening journey into the world of HTTP headers. I had no idea how much was happening behind the scenes every time I visit a website.
It's a lot.
It's a lot. We've covered security, content negotiation, performance optimization, and even like touched on, the privacy implications of headers. What an adventure.
Yeah, it's been a really fascinating deep dive, and hopefully you now have like a much deeper understanding of these seemingly invisible elements that are powering the web.
Absolutely. I
Yeah,
feel like I've gained a superpower. The ability to see the invisible forces that are like orchestrating the flow of information online.
I like that.
But I have to admit, I'm starting to feel a little overloaded with information.
Yeah, I get that.
I know. Maybe it's time for a little break before we jump into the final part of our discussion.
Yeah, that sounds good. Let's pause here and give you some time to process everything we've talked about. When we come back, I think it's time to kind of wrap things up. And talk about why understanding HTTP headers is so important, even for those of us who aren't web developers.
Okay, that sounds like a plan. I'm excited to hear your final insights and wrap up this deep dive into the world of HTTP headers. See you in a bit. Welcome back to our deep dive into the fascinating world of HTTP headers.
Yeah, it's been quite a journey.
It has been quite a journey, right? We've uncovered their hidden powers, explored um, explored how they impact, security, content negotiation, performance. We even tackled that heated Axios versus fetch debate.
Yeah, we really went deep.
Yeah, we
Deep into the inner workings of the web. I hope you're starting to see just how important these seemingly insignificant bits of metadata are in shaping our online
Oh,
experience.
absolutely. I feel like I've gained a superpower,
Yeah,
the ability to see these invisible forces that are like orchestrating the flow of information online.
I love that.
But before we wrap up, I'd love to hear your final thoughts on, why understanding these HTTP headers is so important for anyone really, even if you're not, a web developer.
That's a great question, and it's something I'm really passionate about. You see, today, we're constantly interacting with websites, online services, often without thinking too much about what's actually happening behind the scenes.
Hmm.
But understanding how these systems work, even at a basic level, it can really empower us to make more informed decisions about our privacy, online, security, and our overall
It's
experience.
like being an informed consumer.
Yeah,
The more you know about how things work, the better choices you can make.
exactly. For example, knowing about those security headers, it can help you identify websites that are really taking steps to protect your data.
All right.
You can look for things like, is it HTTPS? Are there security focused headers like content security policy, to gauge how committed they are to security.
That's a great tip. I'm definitely going to start paying more attention to those things. What about content negotiation? How can understanding that help everyday users?
Well, knowing how content negotiation works, it can help you troubleshoot if you're not seeing content in the format that you expect.
Yeah.
You can check your browser settings to make sure that you're sending those correct accept headers. Those are the ones that indicate your preferred language, file types, things like that.
So it's like being able to speak the language of the web, making sure you're communicating your preferences clearly.
Exactly. And when it comes to performance, understanding, how caching works can help you, really optimize your browsing experience.
Okay.
You can clear your browser's cache to make sure you're seeing, the newest content, or even adjust your browser settings to control how long things are cached.
It's like being able to fine-tune your browser's engine, getting that best possible performance for your specific needs.
Exactly. And let's not forget about privacy, as we talked about before, they can be used to track users and collect data, but understanding how this all works, it gives you the power to take steps, to protect your privacy.
Right.
You can use browser settings, privacy focused extensions, even consider using, more privacy conscious browsers that really prioritize data protection.
So it's not just about technical knowledge,
Right.
right? It's about like taking control of your whole online experience.
Yeah.
And making informed choices about your privacy and security.
Yeah, that's exactly right. In a world where data is becoming, increasingly valuable, understanding those mechanisms that govern its flow,
Yeah.
it's more important than ever.
I couldn't agree more. It's like learning the rules of the road before
Yeah.
you start driving. You need to understand how things work to navigate safely and effectively.
That's a great analogy.
So as we wrap up this deep dive, what's the one key takeaway you hope our listeners will remember?
For me, it's this. Even though they're, hidden from view, HTTP headers play a vital role in shaping our online experience. By understanding how they work, we gain this deeper appreciation for the complexity and the ingenuity of the web, and we empower ourselves to make more informed decisions about our privacy, our security, and just how we interact with the digital world.
I couldn't have said it better myself. So to our listeners, I encourage you to keep exploring, keep learning, and never be afraid to peek behind the curtain of the internet. You might be surprised by what you discover.
Yeah, and who knows, you might even be inspired to learn more about, web development and even contribute to building a better, more secure, more privacy conscious web for everyone.
That's a great point. The web it's constantly evolving. There's always something new to learn, something new to explore. And with that, I think it's time to wrap up our deep dive. Thank you so much for sharing your expertise with me. And to our listeners, thank you for joining us on this journey. We hope you found it informative and enlightening.
It's been my pleasure. And remember, the web is a vast and fascinating place. Keep exploring, keep asking questions, and keep learning. The more you know, the more empowered you become.
Until next time, keep diving deep.